there is a fundamental, immutable law of the universe that Silicon Valley likes to ignore. It is not Moore's law. It is not Metcalfe's law. It is the second law of thermodynamics. It states, simply put, that order requires energy. The universe naturally drifts toward chaos and entropy. To reverse that, to create order out of chaos, to organize information, to calculate probability, to generate intelligence, you must consume energy and you must emit heat. There is no free lunch in physics. For the last 20 years, we have lived in a convenient fantasy called the cloud. Marketing departments and tech evangelists have convinced you that the internet is weightless, that it is clean, that it exists in the ether, floating harmlessly above the messy industrial reality of coal mines, smokestacks, and power plants. We swipe a screen and magic happens. But the cloud is a lie. The cloud is not a cloud. It is a physical fortress. It is a 500,000 square foot concrete bunker in Northern Virginia, surrounded by razor wire and diesel generators. Inside, it is filled with hundreds of thousands of silicon chips screaming at 200 degrees Fahrenheit, sucking up the electricity usage of a small city and evaporating millions of gallons of water just to keep from melting down into a slag heap. The internet is a machine. It is a massive industrial engine. It is likely the largest coal and gas-fired machine in human history. And now we have introduced a new beast into this machine, artificial intelligence. While you look at the chatbots, the funny image generators, and the stock prices, the engineers who run the North American power grid are looking at the load charts. And they are terrified because the math doesn't work. We are building a digital god that eats electricity. And we are trying to plug this voracious beast into a grid that was built when Thomas Edison and Nikola Tesla were still arguing about AC versus DC. Tonight, I am going to show you the collision course. We are heading for an energy cliff. The AI revolution is about to slam into the hard, unforgiving limits of physics, geology, and heavy infrastructure. This isn't just about slow internet or lag. This is about brownouts. This is about skyrocketing utility bills for the average family. This is about a war for the electrons that power your life. Let's put this in perspective to understand the scale of the problem. For the last decade, the energy consumption of data centers was relatively flat. This was a miracle of engineering. We got better at making chips more efficient. We moved from inefficient on-premise server closets to massive, hyper-efficient, hyperscale clouds run by Amazon and Google. We squeezed every drop of efficiency out of the stone. But AI breaks that trend. It shatters it. A standard Google search, the kind you've done every day for years, uses about 0.3 watt hours of electricity. It is a simple retrieval task. The computer goes to a database, finds the link, and shows you the link. It's like looking up a number in a phone book. A generative AI query, like asking ChatGPT to write an essay, debug code, or summarize a meeting, uses about 3 to 9 watt hours. That is not a small bump. That is a 30-fold increase. Now, multiply that by billions of daily users. If Google were to switch its entire search engine to generative AI today, it would consume as much electricity as the entire country of Ireland or Kenya, just for one company, just for search. But it's not just text anymore. We are moving to AI video, AI robotics, AI simulations for drug discovery. Every time a chip calculates, it burns electricity. NVIDIA's new H100 chips, the workhorses of this revolution, draw 700 watts of power each. That is nearly the same as a hairdryer running full blast 24/7. Now pack 30,000 of those chips into a single building. A single server rack of these chips now draws as much power as 50 American homes. We are not building data centers anymore. We are building gigawatt scale power plants that happen to produce math instead of steam. But Warren, the techno-optimists and ESG investors say, we will just build more solar panels and wind turbines. The energy will be green. This is the intermittency trap, and it shows a fundamental misunderstanding of how the grid works. Data centers are unique customers. They are what we call baseload demand. They have a load factor of nearly 100%. That means they need full power 24 hours a day, 7 days a week, 365 days a year. They cannot tolerate a flicker. They cannot tolerate a voltage drop. They cannot tolerate a cloudy day or a calm night. Solar panels only work when the sun shines. Wind turbines only work when the wind blows. Their capacity factor is often 20% to 30%. If you try to power a data center with solar, you face a physics problem. You need massive batteries to store the energy for the night. But the battery technology to store gigawatts of power for 12 hours simply does not exist at scale yet. The cost to back up a data center with batteries would cost more than the data center itself. So what do data centers actually run on? Baseload power, natural gas, coal, nuclear. The tech giants love to buy carbon offsets and claim they are 100% renewable. That is accounting magic. That is a financial derivative, not a physical reality. In reality, they are plugged into the grid, and at 3 a.m., when the wind isn't blowing, the grid is burning natural gas to keep those servers running. AI boom is actually a massive tailwind for the fossil fuel industry, because when push comes to shove, Amazon and Microsoft care more about uptime, keeping the servers running, than they care about their carbon footprint pledges for 2030. The physics demands reliability, and right now, reliability means burning hydrocarbons. Let's get into the plumbing, the grid. Most people think the grid is just wires. It's not. It's a complex machine of substations, switchgear, and transformers. The most critical component is the high voltage transformer. These are house-sized metal boxes that step down the massive voltage from the transmission line so it can be used by the facility. You cannot build a data center without them. If you don't have the transformer, you have a billion-dollar building that is nothing more than a paperweight. Here is the problem. We stopped making them. Most of the manufacturing for large transformers moved overseas decades ago. It is a specialized, difficult, low-margin industry. It requires grain-oriented electrical steel and highly skilled labor. 3 years ago, the lead time to order a large transformer was 30 weeks. Today, it is 120 to 150 weeks. That is 3 years. If you want to build an AI data center today, you can buy the chips from NVIDIA. You can build the concrete shell. You can hire the engineers, but you cannot plug it in. Developers are now scouring the globe buying used transformers from defunct factories. They are paying ransom prices to jump the line. They're buying slots in manufacturing lines for 2027 delivery. This is a supply chain crisis that no software update can fix. You cannot code a 200-ton steel box into existence. To see the future, look at Loudoun County, Virginia. It is known as Data Center Alley. 70% of the world's internet traffic flows through the fiber optic cables beneath those streets. For years, the local utility, Dominion Energy, said yes to every data center request, come one, come all. Tax revenue was high, everything was fine. Then in 2022, they hit the wall. Dominion admitted that the physical transmission lines were overheating. They paused new connections. This sent a shockwave through Silicon Valley. The biggest choke point wasn't land or money or zoning. It was the physical capacity of the copper wires to carry the current. Now, data centers are fleeing Virginia. They are going to Columbus, Ohio. They are going to Des Moines, Iowa. They are going to Atlanta. They are chasing power capacity like gold miners chasing a vein. But wherever they go, they eat the local grid capacity. In Ireland, data centers now consume 19% of all the electricity in the country. By 2030, it could be 30%. Imagine if 30% of your country's total power generation went to foreign tech companies, leaving the rest of the economy to fight for the scraps. This creates political tension. The citizens of Ireland are asking, why are we facing brownouts so Facebook can train an AI model? This is the beginning of the energy nationalism era. Communities will start fighting back against data centers. They will refuse the permits. They will tax the power. The Not in My Backyard movement is coming for the cloud. So the tech giants have realized the grid is broken. They've realized renewables are too intermittent. What is the solution? This is the biggest irony of the 21st century. The same demographics and environmentalists who hated nuclear power for decades are now working for tech companies that are desperate for it. Microsoft just signed a deal to restart 3 Mile Island. Yes, that 3 Mile Island, the site of the worst nuclear accident in US history. They are paying a premium to turn Unit 1 back on exclusively to power their AI ambitions. Amazon bought a data center directly connected to the Susquehanna nuclear plant in Pennsylvania. They are buying the power behind the meter. This means they aren't using the public grid. They are sucking the juice straight from the reactor before it ever touches the public wires. This changes the game. It means big tech is privatizing the most reliable power sources in America. But here is the catch. Building new nuclear plants takes 10 years and billions of dollars. The Nuclear Regulatory Commission is incredibly slow. Small modular reactors are promising but unproven at scale. So we are in a gap period, the energy valley of death. We have the exponential demand for nuclear today, but the new reactors won't be ready until the mid-2032. In the meantime, we burn gas, lots of it. Let's talk about rocks. There is no AI without electricity. There is no electricity without transmission. There is no transmission without copper. Copper is the nervous system of the modern world. An AI data center uses tons of copper in the chips, in the servers, in the cables, in the cooling systems, and in the power lines connecting it to the grid. The world is currently facing a structural shortage of copper. We have not discovered a massive new copper deposit in decades. The existing behemoth mines in Chile, like Escondida and Peru, getting old. The ore grade is declining. This means you have to dig up twice as much rock today to get the same amount of metal we got 20 years ago. And opening a new mine takes 15 to 20 years of permitting, environmental studies, and construction. Goldman Sachs calls copper the new oil. The demand from AI, combined with the demand from electric vehicles and the green transition, creates a copper squeeze. If the price of copper doubles, the cost of the entire energy transition doubles. The tech companies operate on Moore's Law, expecting things to get faster and cheaper every 18 months. The mining industry operates on geological time. Silicon Valley is about to learn the hard way that you cannot iterate a mine. Techno-optimists will tell you, don't worry, chips will get more efficient, the algorithms will get smarter, AI will learn to use less power. This ignores a fundamental economic theory called Jevons paradox in the 1,860 seconds. Economist William Stanley Jevons noticed something strange. When steam engines became more efficient and used less coal to do the same work, coal consumption didn't go down, it went up. Massively. Why? Because when energy becomes cheaper and more efficient, we find new ways to use it. We apply it to problems we previously ignored because they were too expensive to solve. If AI chips become 50% more efficient, we won't use 50% less power. We will build models that are twice as big. We will put AI in your toaster. We will put AI in your car. We will run AI agents 24/7 to manage our calendars and buy our groceries. Efficiency does not reduce consumption. It induces demand. As the cost of intelligence drops to zero, the demand for intelligence will become infinite, and therefore the demand for energy will become infinite. We are not going to conserve our way out of this. Thermodynamics says energy doesn't disappear, it turns into heat. The more power a data center uses, the hotter it gets. If you don't cool the chips, they fry, they stop calculating. The most efficient way to cool massive data centers is water evaporation. You run water over the cooling towers, it evaporates and takes the heat away. A hyperscale data center consumes millions of gallons of water a day. It competes with local agriculture and drinking water supplies. Now, look at where they are building them. Arizona, Utah, Texas, the desert. Why? Because land is cheap and solar power is abundant, but water is scarce. We are already seeing local farmers fighting with Google and Microsoft. Why do you get the water for your servers when I can't water my crops? In Uruguay, there were protests against Google's water usage during a historic drought. This is the hidden cost of your ChatGPT query. It is thirsty. Microsoft has pledged to be water positive. They are trying new cooling technologies like immersion cooling. But you cannot defy physics. Heat must be moved. And moving heat requires resources. So who pays for this infrastructure build out? You do. When Amazon buys a nuclear plant and takes that power off the grid, the supply of reliable baseload power for everyone else goes down. When demand goes up and supply goes down, price goes up. It is economics 101. Grid operators like PJM in the Northeast are already warning that electricity prices are going to spike in capacity auctions. Prices in some recent auctions have jumped 800%. Your household electric bill is going to subsidize the AI revolution. Utilities will have to build new transmission lines, new substations, and new gas plants to support the load. The cost of that capital expenditure is passed on to the ratepayers. That's you. We are entering an era where families will compete with chatbots for electrons, and the chatbots can pay more. A data center generates massive revenue per kilowatt hour. A household does not. In a free market without government intervention, the energy flows to the highest bidder. Finally, we have to look at the global board, China. China's not debating whether to build power plants. They are building them. They are building nuclear. They are building hydro. They are building coal at a record pace. They are building the world's largest ultra-high voltage grid to move power from the west to the east. They control the supply chain for the transformers. They control the refining of the copper and the graphite. They control the processing of the rare earth minerals. If AI is indeed the new nuke, the defining military and economic technology of the era, then the country with the most stable, massive power grid wins the race. In the US, we are paralyzed by regulations. It takes 10 years to permit a transmission line. It takes 8 years to permit a wind farm. Our grid is fragmented, old, and legally gridlocked by local municipalities and environmental lawsuits. If we cannot fix the physical layer, the concrete, the steel, the wire, we will lose the digital layer. You cannot have 21st century software running on 20th century hardware. For 20 years, the digital world outperformed the real world. Software stocks, crushed energy stocks, SaaS companies were valued at 50x revenue, while oil companies were left for dead. But the pendulum is swinging back. The AI power paradox is the signal that the physical world matters again. You can print money at the Federal Reserve. You can code software in a dorm room. But you cannot print watts. You cannot code copper. The constraint on the future is not ideas. We have plenty of ideas. The constraint is physics. For investors, this means the next big winners might not be the tech companies themselves. It might be the companies that provide the shovels for this gold rush. The natural gas pipeline operators, the uranium miners, the copper producers, the grid equipment manufacturers, the owners of unregulated power plants. The virtual world is expensive. The physical world sends the bill. And the bill is finally coming due.